Algae. It's one of the oldest life forms on the planet, dating back over 3 billion years, yet this simple ancient life form now has the potential to revolutionize our modern approach to agriculture. For the past 6 years, biochemists and engineers at Aurora Algae have dedicated themselves to the technology and science of growing algae that yield high-value oils and proteins. Scientists at Aurora have bred special strains of algae, which grow and reproduce at a much faster rate than wild varieties. Our special strain of Nanochloropsis algae is an oil-rich, single-celled variety capable of doubling in volume every day. And at our production facility in Karratha, Western Australia, we are perfecting an agricultural technique that grows large volumes of this algae in saltwater ponds while consuming carbon dioxide as a nutrient. This revolutionary platform has the potential to transform modern agricultural production, creating a sustainable alternative to meet the growing demand for numerous high-value products, including pharmaceuticals, nutritional supplements, animal feeds, and biofuels. The process starts in the lab. Scientists in our Silicon Valley laboratory continue to search for new, improved strains, sorting and analyzing tens of thousands of algae samples. This can be a very time-consuming process. Fortunately, robotics and new technological developments are making this work more efficient. We start by isolating individual strains of algae, focusing on those that appear to have the most promising characteristics. Using a variety of specialized equipment, we study minute differences that may help optimize our crop yields or improve the quantity or quality of products we extract from the algae. Desirable attributes include higher lipid or oil content, the ability to grow at higher temperatures, the ability to process greater quantities of CO2, and the ability to grow in water with higher salinity. Here, our liquid handling robot is extracting fatty acids from algae samples. The autosampler then feeds the samples into a gas chromatograph, which analyzes the oils in each sample, screening for strains with higher oil content. Our fluorescence imager allows us to measure an algae strain's ability to process sunlight through photosynthesis, screening for strains with higher tolerance and better utilization of sunlight. When a promising new strain is discovered, it is isolated for further study and evaluation. DNA sequencing and genetic analysis allows us to better understand what causes the specific attributes of different algae strains. Once we understand the genetic code, we can then breed special strains that emphasize these characteristics. Promising new strains from our California labs are sent to our cultivation facility in Western Australia for outdoor validation and production. Our high-tech farming method, combined with our proprietary algae strains, leads to unprecedented crop yields, which double in volume daily. This pilot production facility is designed to produce up to 15 tons of dried algal biomass per month in 6 one-acre ponds. Algae strains sent from our California lab are received in the on-site cultivation lab. Here, the strains are submitted to further study and analysis while growing them in increasingly larger containers. Once the samples have been validated and grown to sufficient volume, they are transferred to outdoor microponds. During this stage, and continuing throughout the entire cultivation process, our quality control lab monitors a variety of daily parameters, including salinity, growth rates, purity levels, and algae density. Once outdoor testing and validation is complete, the algae is ready for introduction into increasingly larger raceway ponds, each one approximately an order of magnitude larger than the prior one. From 50 square meter inoculum ponds to 400 square meters, and finally to the 4,000 square meter or 1 acre growth raceway ponds. The algae in these ponds are grown in seawater, drawn from the edge of nearby Nickel Bay. Although our algae thrives in brackish water, we still need to filter out impurities and lower the salt content prior to depositing the water into the growing ponds. We then run the filtered water through a reverse osmosis system to further lower the salinity. The resulting filtered, low-salinity seawater is deposited into a reservoir, which feeds the growth raceway ponds through a system of overground pipes. The algae in the growth raceway pond is fed a steady stream of carbon dioxide and other nutrients, which contribute to this crop's amazing growth rate. Through a combination of human monitoring, automated controls, underwater jet systems, and custom mixing solutions, nutrients are constantly circulated throughout each individual pond. Our distribution control system, or DCS, ensures that the ponds are maintained in a constant balanced state, optimized for maximum algae growth and purity. The DCS controls everything from seawater intake to harvesting operations. The system even provides remote access and control, allowing technicians to monitor current and historical values of any parameter from anywhere in the world. For harvesting, algae-rich water from the ponds is pumped first into a buffer pond, and then to the nearby harvesting station. Its first stop is a series of tanks where a flocculant is added. It is then run through a dissolved air flotation system, or DAF. The DAF skims floating flocculant algae from the top of the basin, depositing it into a concentrate basin, and the leftover clarified water is recycled into the growth raceway ponds. From the concentrate basin, the algae is run through a centrifuge to remove excess water. The clarified water is again recycled to the growth raceway ponds. It is then processed by a second centrifuge where residual salt is washed out, leaving purified algae paste. The purified algae paste is then sent through a dryer, resulting in a fine textured powder, which we call algal grain. An alternate drying method is purely organic and involves spreading the purified algae paste over open-air drying beds and letting it bake in the sun until dry. The dried algal grain is then shipped to the United States for refining and processing into algae-based products. Most of the dried algal grain is shipped to our processing partners who operate commercial-scale extraction and refining equipment. A portion of the shipment is also sent to Aurora headquarters, where we experiment with a variety of processing methods for the ultimate production of a variety of consumer products. Prior to extracting oil from the algal grain, it is converted into pellets using heat and compression. The oil is extracted from the algae pellets, producing high-protein defatted pellets and solvent-laden oil. The solvent is vacuum stripped from the crude oil and recycled, and the defatted pellets are later processed into animal feed and protein products. The crude algal oil is further processed into C16 oil for biofuel and EPA, an omega-3 essential fatty acid, for nutritional supplements and pharmaceuticals. The two main stages in processing the crude oil are conversion and refining. In the conversion stage, the crude oil is put through a reactor, which uses a solvent to further break down and separate the different fats and other components of the crude oil, and allows additional solids to be filtered out. After filtering out waste solids, the solvent is again recovered and recycled, leaving crude fatty acid methyl esters, also called crude FAMEs. In the refining stage, a wiped film evaporation unit is used to further refine the crude FAMEs, separating wax from the FAMEs. The resulting pure FAMEs are then put through a fractional distillation process, resulting in C16 oil, also known as biodiesel. The same fractional distillation process is also used to distill EPA methyl ester, which is then further refined through a process called ethyl transesterification to produce our omega-3 EPA product, A2-EPA Pure. And that is how algae, one of the oldest life forms on the planet, is now providing humans, one of the newest life forms on the planet, with thoroughly modern forms of food, fuel, and pharmaceuticals. We are entering a new era in modern agriculture, and Aurora Algae is leading the way.